Okay, this is the assignment 2 and in relation to multiple imputation. And my name is Clayton Joliveira, right? And I'm going to talk about the research they often encounter missing values in their data set. And, um, and these can cause a problem for their analysis, right? So there are many methods that they can be used. And one of the methods that are going to explain in this um, video is multiple imputation. Types of missing data. Okay, there are 3 classifications of missing data. Defining our severity by Rubin in 1976. Right, so the first one is missing complete at random. So if the missing does not depend on any information in the data set. So that missing data does not depend on anything. So for example, the observation with missing blood pressure are just a random subset of observations. So there are no systematic difference between the missing and observed blood pressure. So one test that we can use to find that if it's a MCAR, which is missing complete at random, is the little test. The second classification is missing at random. So if the missing does not depend on the item or variable itself, but on the other observed information in the data set. So for example, a registry examining the pressure may encounter data that are MAR, which is missing at random. If male participants are less likely to complete a survey about the pressure and severity than female participants. One test that we can use is first we have to create dummy called missing or not, and then do a t-test in order to find out if it's missing at random. And the third classification is MNAR, missing not at random. If the missing depends on the missing variable or item itself. For instance, if a questionnaire item is too sensitive to answer. For example, will be individuals being surveyed could potentially leave fields blank if they use drugs that are currently illegal out of fear of being prosecuted. So there is no test to find out, if it's a missing not at a random. So how do we deal with that? How do we deal with the missing data? So there are a few methods to use. So the first one is the list-wise deletion, with a delete a case from an analysis if it's missing any value used in analysis. For example, so if I go to the Excel here, so all these variables here that are missing data, right? So what it's going to do is going to delete these 2 and this one here, so 3. So that means that my data set is going to leave only those 3, so I'm going to miss 50% of my data set, which is not a good approach. Okay, so mean imputation, what does is going to fill in the mean for any given missing value, right? So this is going to reduce the variance. So for example here, I'm going to get the mean of this age, and I'm going to add here the mean of the experience, the mean of the salary, and so on. So here you'll be able to see the mean of age will be 29, so I fill there. The mean of the experience is 7, and the mean of the salary is 134. So this is which is also called single imputation. Okay. So we have the regression-based imputation. So this is just use a predictor to adjust the given cell score based on what is known about the case. So we start with the mean, then others also subtract based on understanding regression coefficiency for the predictors. Okay, so it's a more modern method. We also have a pairwise deletion. It only removes records from the analysis in which they are missing data, but retain the records for analysis in which they have the complete set of data, used only in the data set of the less than 5 missing data. Okay. So the next, multiple imputation. So multiple imputation is a process used to fill in the blanks of a data set so that a full and complete set of data can be used in analysis. So it might deal with the missing data. So it's strongly considered using if you have 5% or more missing data. Right, so for example, here we have just well, we have a really small data set, but if we had way more than that missing data, we can use that. But for this one, for this example here, we can just use a simple single imputation. Okay, so single input means to fill in with single imputation methods such as means, median, or some other statistics is used to input the missing values. Single imputation is not a good method as it can provide uncertainty about which value to input. So if I had many of missing data here, if I put all the, for example, in this case, 29 of all of those 20 missing data, that would not be a good approach for my analysis. And also multiple imputation allows uncertainty about missing values by creating many different data sets which are then combined and make the best value. So I will explain this later. So the advantages and disadvantages of multiple imputation: it can reduce bias, improves validity, increase precision, and result in robust statistics. And the disadvantages, the data has to be marked, right? Miss and the random. So we assume whenever using MINES, which is the library used in R, it's always assumes that it's missing at a random. And it's more complex. You need power on that machine, depending on the size. So for example, I'm going to give one as an Excel and then So in Excel, so we have this data set, right? We have a few missing data there. Okay, so what we're going to do is first, we're going to, as purchase, there is no missing data, we're going to remove that, right? This is the first step in order to do multiple imputation. So now input all missing values with the mean. So this is the simple imputation that we just did. So I'm just adding the simple on each variable. So I'm just adding the mean of that in there. So once that is done, so I go to the second step. I'll be going to run a linear regression model on the fully filled rows to predict the age. So for example here, I'm just run a simple linear regression here. So for example, I want to see, this one is age and experience. So the experience of the 11, so I'll go here, 11 will be around there. So around there, so maybe I can say it's 35 or 36. So as per our analysis, we got 36 there. So step 3, we're going to run a linear regression again for the experience, right? Because we did for age. So we add age there. We remove the value of experience, and then we'll run the linear regression, and then we get to the value and we add it there. So this is 1.8. So it means that my age 25, if I have experience of 1.8, my salary should be around 50. So experience and salary. So if I have 1 point, will be around here. So this will be the value that my salary. Okay, so this is the step 3. Then I'm gonna do another one, step 4. I'm gonna run linear regression again for the salary. And so here I'll remove the salary, the value of the salary. So I'm gonna leave the experience and the age, and then I'm gonna predict the new salary for this. Once that's done, I have the full first data set. Okay, so this is my first data set, right? And then now, what I'm gonna do, I'm gonna do the second iteration, and I want to see if this iteration will be better than the first one. So this second iteration, I'm gonna do the same. So instead of using the mean in here, in the first iteration here, in the first step, I'm going to use the I'm going to use the value that I got after I run all the regressions, these values here, right? So once I do that, I got this value of this linear regression. So my goal here in this different matrix is to reach to 0 or as close as possible. Once I reach that, that is the best iteration or the best data sets to be used for my analysis. So here I can see I did the second iteration. I got 1.38 on my age, 0.93 and minus 7.96. So when I do again the second and the third iteration, so you can see that the different matrix is going smaller, and also the age increased, the experience as well, a little bit compared to the last one, and the salary, right? And then I run the iteration again for the fourth time. I'm getting 35. So this is the 34th, this is the fourth iteration. And the ninth, so 25 is just 1 year, we reached 50, which is, that's acceptable. 3 years, 80,000, 5 years, 110. So 35 will be around 200,000. And you can see the different matrix is really close to 0, and that's what we want. So here we can confirm that this data set here is the best to be used for analysis, as the imputation is close enough to what it should be. Okay. After that's done, so we did an Excel, now we're going to use R. In R, we're going to use the National Health and Nutritional Examination Study. Okay, so we have 4 variables there. We have age, BMI, hypertensive, and total serum cholesterol. And this data set has 25 rows, and we have age. So if I go here for the data set, let me run it here first. So if I go to the data set, you can see there are quite a few missing data there. So age seems to be okay, so we don't need to do anything there. You can see 1, 2, 3, right? That's the maximum. And we have BMI, loads of missing data. We have hypertension, hypertensive, and also the cholesterol. Okay. So here, what are we going to do? We're just going to have a summary of the data set, so we can see that the median there of the BMI is 2656. Hypertension, we can see it should be yes or no. So this is wrong. So what we have to do, we have to clean the data. So in here, I'm cleaning the data. You'll be able to see better. So we can see here, yes, we have 13. No, which is, no, we have 13. And yes, we have 4, right? And NAs means that we don't have any value assigned to that. So hey, 8. BMI we have 9, and for cholesterol we have 10. So here I'm just running the percentage. We can see here I'm just running the percentage here of the data set. I can see that 36% of my BMI data set is missing, and the hypertensive is 32%, and cholesterol is 40%. Wow, it's quite a lot. You can see here as well, we can see that the age is nothing. I have a few missing data here for hypertensive, BMI, and cholesterol. And here as well, we'll be able to see in this plot, margin plot, that we have 10 here on the cholesterol, and a 9 missing data here on the BMI. So what we're going to do, for example, in a simple imputation. So if I run this one here, I'm just adding a simple imputation on this data. As you can see, right? We have the 2656. So this is what's going to happen. And we don't want that. We don't want that because this is biased. The great bias to our data set, and that's not what we want. We see we have 191.4 there, and this is not what we want because this is the simple mean imputation. Okay, so what we're gonna do here, I'm just gonna use mice imputation. So I'm going to, as we have 5 columns, right? So we have the variable there age, as we don't have any missing data, I'm not going to use nothing. I'm going to use predicted mean matching for BMI, logRat, which is the logistic regression, which is 1 and 2 for hypertensive, and the last one is the cholesterol. I'm gonna be using only the predictive mean as well. So once I run this one here, and also here you can see I'm running 5 times, so I'm creating 5 data sets for my analysis, like to find the best approach. So creating 5, taking 1. So there you are. You can see that I have created 5 data sets. So now let's have a look at them. Okay. So if I run this here, so here this is I'm checking the first data set and BMI first. So be the unclean data set would be this data set here without the NAAs. I'm just getting the mean of that. Okay. So once I have that, so my goal is to find a data set that has close to this mean. So here, when I run this input data set, imp and BMI, right, I can also get the BMI here, both of them. I'm trying to find a data set that is close enough for that. So for example, here, this is 1, 3, 4, those are the variables that are missing, the rows that are missing. So I'm just inputting them here. So here, let's see. So 27, okay. Okay, it's close enough. We'll have those, that's a little bit far, and then I have those two. Okay, let's see this one here. So it's a little bit far, 230, 330, 35, so it's kind of far away of 2656. Right, so let's see this one here, 27, 29, 28. So this one here seems to be a little bit closer. What about this one here? 28, 28, 27. It's a little bit more. And this one here. Number 4 seems to be okay. Number 5, 25, 25, 26. There's 133 there, 130. So, wait. The 230s there. I think number 4 is the closest for closest data set. So what I'm going to do here, I'm going to change here to 4 and run this. So what I'm doing here now, you can see that the mean now from my new data set, here was 2656, now is 2666. So increase a little bit. And what I'm doing here, I'm just I create a new data set there, and I'm just run the BMI clean data set. Finally, what I'm doing in here, so let me run this again. I'm just plotting the new data set to show the actual values and the missing values, and just to check if my imputation is correct. This is a great tool where shows us exactly what where the missing values are going to be plotted. So for example here, in the age, as we don't have any missing values, so it shows everything is okay. So BMI, you'll be able to see all the blue ones means that the actual data, and the red ones are where we plot my input value. You can see that they're really close, really nothing really far away or different, right? You can see that it's doing really well, the imputation that I have selected there, the data. And let's see XY plot. So I'm just checking the BMI and the cholesterol. So the BMI and the cholesterol there, and see, yeah, seems to be good as well. There's nothing showing wrong. Well, seems to be like nothing nothing, for example, the BMI, nothing on the top that's not supposed to be, for example, one in the corner here. So everything's close to the ones that we have already there, so which is really good. So to conclude, there is some researchers that advise to use the multiple imputation for missing data, right? And because it really helps you to fill in that gap, and where you can do the analysis and finish with your analysis. And that's it. Thank you. And if you have any questions, please send me an email, and I'll be available to answer any questions in relation to it. Thanks very much, and bye.